Let's take a look at example. So to find the vertical asymptote, as you can see here from the tips, to find the vertical asymptote, we have to find the value of x that causes the denominator to be 0. So, for this example, we know that the denominator is x plus 2. We can see that the denominator is x plus 2. So we have the vertical asymptote x plus 2, the vertical asymptote x plus 2 equals to 0 and x is equals to negative 2. What we have to do is we can do number line to represent our vertical asymptote. So this is vertical asymptote. Our vertical asymptote, which is x equals to negative 2. So we need to find x from the left and x from the left, x from the right. So for x from the left is negative 2 from the left and this is negative 2 from the right. So we can assume the value for any value. So negative 2 from the right, we can assume the value is negative 1.9. As for negative 2 from the left, we can assume the value is negative 2.1. Okay, so let's proceed to the working. So now we need to find limit fx, which is x plus 3 over x minus 2, when x approach to negative 2 from the right. Okay. So for the numerator, we can substitute the value of negative 2. So we have negative 2 plus 3 equals to 1. In the denominator, if we substitute negative 2 into x, it will get a 0. So this one, x plus 2. So if we substitute negative 2 into the denominator, we will get 0. So what we need to do is we can use the value from the right here, which is negative 1.9. We can assume. So we know that negative 1.9 plus 2, you will get positive number. So you get positive value. So here, it will be 0 from the right. Okay? So 1 will be 0 positive, we will get positive infinity. So we'll do the same for negative 2 from the left. So we have limit x approach to negative 2 from the left. X plus 3 over x minus 2. X plus 2. So for the numerator, if we substitute negative 2, we will get negative 2 plus 3, which is 1 over. So the denominator, negative 2 plus 2, we will get 0. So what we need to do, this is the value for negative 2 from the left. So we assume the number is negative 2.1. So if we substitute negative 2.1 plus 2, we will get the negative number. So here, we will get 0 from the left equals to negative infinity. You don't need to you don't need to show your substitution of negative 1.9 or negative 2.1 into your working. So now we get negative 2 from the right, we get positive infinity. Negative 2 from the left, we get negative infinity. So we can conclude our answer different to negative 2 is a vertical asymptote. Vertical asymptote for fx. Okay. So let's proceed to the next example. So now we have 1 over x squared minus 1. So if we simplify this function, we get 1 over x plus 1, x minus 1 if we factorize x squared minus 1. So now the denominator, the vertical asymptote, we have to find the vertical asymptote by looking at the denominator. So we will have x plus 1, x minus 1 equals to 0. And then we will have x equals to negative 1 and x equals to 1. So these two are our vertical asymptotes. So now we have two values of x. So we need to do for both of them. So let's do for x equals to 1 first. So for x equals to 1, well, for x is not equals to 1, we do the number line. Yes, we need to find 1 from the right and 1 from the left. So 1 from the right, it to the right, that's 1.1. So this one, let's see, we got 0.9. 0.9. Okay, so now we want to find limit x approach to limit fx, where we have 1 over x plus 1, x minus 1. We can use this one, the one that we factorize here. So limit x approach to 1 from the right equals to, okay, so for x plus 1, we can substitute the value of y. 1 plus 1, we get 2. So 1 over 2. And for this one, x minus 1, if we substitute the value of 1, we get 0. 1 minus 1 is 0. So, but here we got limit x approach to 1 positive. So we can take the value of 1 positive, which is x, which is 1.1. So 1.1 minus 1, we will get positive number, positive value. So we can put 0 positive here. Equals to 2 times 0 positive, we get positive 0, 0 positive. So 1 will be 0 positive, and that will be positive infinity. So now we need to find 1 from the left, limit x approach to 1 negative. 1 over x plus 1, x minus 1 equals to, again, 1 over. So for this one, 1 plus 1, we will still get 2. So this will be 2. And for this one, 1 from the left, if substitute 1, we will get 0. But 0 from the left, so we can use the value 1 from the left, let's say 0.9. So 0.9 minus 1, we will get negative value. So that will be 0 from the left. Okay. We have finished for x approach to 1. So now we need to proceed with for x equals to negative 1. And remember, we have 2 values of x here. So let's do the number line to make it easier for us. So negative 1, we have negative 1 from the right, negative 1 from the left. So negative 1 from the right, we can put here negative 0.9. Negative 1 from the left, we can put negative 1.1. So we have limit, again the same function, x plus 1, x minus 1. When x approach to negative 1 from the right. Now, we just substitute 1 over, so negative 1 plus, if we substitute here, negative 1 plus 1, we will get 0. But we have negative 1 positive. We have negative 1 from the right here. So we can take the value of negative 0.9. So negative 0.9 plus 1 equals to a positive number. So that will be 0 from the right. 0 from the right. Negative 1 minus 1, you will get negative 2. So now we have 1 over 0 positive, negative 2, and this will be negative infinity. Again, the last one, we need to find limit 1 over x plus 1, x minus 1, when x approach to negative 1 from the left. So now we have 1 over this one, negative 1 from the left. Substitute here, we can take the value of negative 1.1. So if we substitute negative 1.1 plus 1, you will get negative number. So, we will get negative number. So this will be 0 from the left. So negative 1 minus 1, we will get negative 2. So now you have 1 over 0 negative times negative 2. This will be positive infinity. Okay. So you can see here, for x equals to 1, we got the answer positive infinity, negative infinity. For x equals to negative 1, we got negative infinity, infinity, positive infinity. So we can conclude our answer as x equals to 1 and x equals to negative 1 are vertical asymptote.